Oops, I ran out of time there. But to solve this portion, if I set this factor equal to 0, well, I cube both sides and I get 1. So really, I know my critical values are going to be 0 and 1. There's many ways to write that. There are different ways to solve it. I thought factoring might be the easiest. So let's speed this up a little bit and make our sign chart. And this is hard plugging the numbers in to something that's to the 2/3 power. But when you realize that this first factor, x to the 2/3, basically I'll take the cube root, but then I'll square it. So this factor right here, no matter what I plug in, once it's squared, is going to be a positive number. And this, you just have to figure out, is that going to be positive or negative? Well, I have 2 negatives here and 1 positive, so the answer to my problem right from the beginning is just, I have a point at 1. And if I plug 1 into my original function, that will tell me the height. But I wanted to show you just a little bit more with this one. It is kind of odd, and this is one of these situations where you have 2 sets of concavity that are the same, so there's not an inflection point. Inflection points occur when concavity changes. But here's why I wanted to show you. The second derivative test. If you know you have to find concavity already, the second derivative test can help you with mins and maxes too. Go ahead and take a look at the critical values of this first term. Remember, picking out the numbers that you can factor out, a common number, isn't too bad. Picking out the variables to factor out, always take out the smaller of the degrees. When I do this, I am left with x to the 1/3 minus 2. Okay, so it looks like my critical values for the first derivative were 0 and whatever 2 cubed is, 8. So it will take you a minute to solve that, but you find 0 and 8, and you think to yourself, all right, 0 and 8, is that a max, is that a min, is it increasing or decreasing? I can help you with one of these. Right here, 8's a critical value. It's probably a max or a min or something like that. But this section is concave up. If you have part of the graph that's concave up, what do you think that critical value is going to be on that? Any critical value on a section that's concave up must be a minimum. So we know that if we were looking for maxes and mins, if we were looking for increasing and decreasing, 8, because it's on a concave up section, is going to be a minimum. You can find the actual value over there for whatever the height is. Go ahead, mark that down. It'll be great. The original function told us it was -16. Now the weird thing is here, I still can't figure out what 0 is. Second derivative is no help either. I know it's concave down and then concave down again. This is one funky looking graph. You would need to make a sign chart to find out what happens here, but you might have an idea. There really is just some undefined portions to this. I have a graph that is concave down and then concave down again. And then there's an inflection point and then concave up. But that's not smooth up there. That's actually kind of a pointy place, and therefore it was undefined. So that is a really odd function. To find inflection points or concavity, use the second derivative. The rest of this we'll discuss a lot later when we start putting all of this together into big graphs. Thanks for your time. See you in class.